Hello everyone. So in this video, we are going to see a series RLC resonance based question. So in this circuit, you have a voltage source 60 sine omega t, and the omega frequency of the source is variable. And at omega equal to 10 radian per second, you will have a maximum currents, and at omega equal to 4 radian per second, you have the maximum current of 4 ampere. So this I maximum current is this current. Okay, and basically this current can have also have power factors of angle also. So let me give correct it. So maybe the current is I max sine omega t plus theta. Depending on the impedance on the frequencies, the theta will vary. Okay, but here I'm only showing the magnitude in the graph. At 10 radian per second, you have 6 ampere of maximum current, and at resonance frequency, the circuit operates at resistive circuit, and at 4 radian per seconds, your maximum current is 4 ampere. Okay, now we have to find out L and C values. 10 ohm is the R value. Okay, so what are the findings from this particular graph? My resonance frequency is 10 radian per second. Why it is resonance frequency? Because at resonance frequency, the Z of this RLC, whatever the impedance will be offered, that Z will be minimum and your current will be maximum, right? So that's why it is a resonance frequency. And if you see the overall Z of the circuit at any frequency, that is R plus j omega L minus 1 by omega C, right? The modulus of this Z is simply R square plus omega L minus 1 by omega C whole square. Now, I know the maximum current is 4 ampere at 4 electrical radian per second frequency. Okay, so I can write my I of t is simply 60 by mod z sine of omega t plus theta, and the angles and all I'm not showing here. Okay, so that angle will also come into this theta, so that you can uh, take but it doesn't matter because I am only interested in the magnitudes and all. Okay, and at omega is equals to 4 radian per second, the maximum value, this is the maximum value, right? 60 by mod z, 60 by mod z simply become 4. So the mod z value is 15. So your mod z value, if you write, R value is 10. So that is 100 plus 4L minus 1 by 4C is equals to 15, right? So let me use another one. So 100 plus 4L minus 1 by 4C is equals to 15. So if you take square in both the side, you will get 4L minus 1 by 4C is equals to 15 square. Okay. So if you calculate it, you will get 4L minus 1 by 4C is equals to 15 square. 15 square minus 100, you will get 125. And you need to find out the L and C, right? So 4L minus 1 by 4C is equals to plus minus 2 power 125. Now, here is the main things will come, like why, whether it will be plus or minus, that we need to understand. Let me check the calculation again. Okay, see, uh, that thing is pretty clear. So the current waveform is given like this. Okay, and this is 10 radian per second and 10 radian per second, and somewhere here I have 4 radian per second. Now, for a series RLC circuit, if you see the reactance diagram at resonance frequency, your reactance will be 0, right? and this is how your reactance varies. And for omega less than resonance frequency, your X is negative. That means your circuit behaves as a capacitive circuit. And for omega greater than 0, omega greater than resonance frequency, so this is my resonance frequency omega naught. So for omega less than omega naught means this region, your X is negative. Your X is negative. That means it is a capacitive circuit. And for omega greater than omega naught, X is positive. That means your X is the circuit is inductive circuit. And basically X is nothing but j omega L minus 1 by omega C. This is your X basically. So for this region, your overall X is negative. That means this particular quantity will be negative. That means 1 by omega C will be larger, right? And 1 by and omega L will be a smaller quantity. Okay. So if you see, since my frequencies lies less than omega naught, okay, that means this particular quantity has to be negative. So I must take negative sign here. Like, I hope this explanation is clear, because your omega lies at less than omega naught, that means resonance frequency, your omega L minus omega C must be negative. So that's why I have given a minus sign here. Okay. So now you can do the calculations. So this is your equation number 1. And also you know the resonance frequency omega naught is equals to 1 by LC. That is LC is equal to 1 by 10 whole square, right? So 0.01. So this is equation number 2. Now you have two equations, you have two unknown L and C. You can basically find out what to do. Okay, maybe I can add the steps here. 4L minus 1 by 4C is equals minus root over 125, and LC is equals to 0.01, right? C is equals to 0.01. So maybe I can put C is equals to 0.01 by L. So 4L minus 1 by 4 into 0.01 by L, so minus 125. So I'll get mm, take L take L common, 4 minus 1 by 4 into 0.01. I'll get 25 minus 125. So L would be 125 by 25 minus 4, 21 over 125 by answer. It will be 0.5 CT23 Henry, and your C will be 1 by answer into 0.01. It will be 0.0187 Farad. Okay, I hope it is clear. The main catch was in this expression, okay, whether you have to go with plus or minus. Okay, that comes from the reactance diagram. Okay, from this discussion, if you have any doubt, you can ask in the chat box. Thank you.